welcome everyone. Let's dive right in. And partially, I probably don't need to convince you, but still to level set on this. So today, what you see all too often is that you still have a ton of different systems. And you have your mental breaks when you go from one thing to the other, to the next. Maybe the metadata structure is different. The green thing is red, the red thing is yellow, what have you. It takes some mental effort to jump in between all your different data sources. And that's not great. So rethinking this a little bit, and you probably know where I'll end during this meetup. But before this, let's go a little bit to the basics, to the buzzwords, and to the things which people usually don't tell you about. Of course, those are also super important. There's a little bit of a dirty secret in the industry that what used to, or what is cloud native today, is basically internet scale of 2 decades ago, which stands to reason, of course, without the internet, the cloud wouldn't exist. So it kind of needs to be larger and running ahead of cloud. And if you look at power stations, or if you look at water plants or what have you, this combination, like this focus on metrics and events, is pretty much standard in all infrastructure industries. It goes even wider, like back to whaling and sailing boats and everything. And the nice thing about this is that a lot of those practices map very well onto different things. Going a little bit into the buzzwords. Buzzwords are usually with a kernel of truth, and that is actually useful, and you should try and find out what that kernel of truth is. But on the other hand, you have the thing of cargo culting. Cargo culting is defined as, or has been coined as a term when in the Pacific Islands, certain indigenous people or folks, doesn't matter, observed military people building airports and such, and then received or perceived that the gods sent cargo and gifts from the heavens. And they wanted to have the same. So until this day, there are religions in this region which still build runways and small light towers and control towers and such to please their gods. The lesson here is they observed behavior without understanding why that behavior took place, and they observed the results, and they just copied the observed behavior. They did not change, or they did not actually understand what was happening and try and go for that thing. They just observed the behavior because they couldn't dive deeply enough into this. So if there's one thing about buzzwords, be super careful if you're just changing the name, or someone else is just changing the name of what they're doing. It's a lot about changing the actual behavior. In this context, I personally use monitoring and observability interchangeably. While monitoring has taken on this meaning of collecting and not using data, it's inherently the same. You just need to properly take care of your data and actually work with it. Extremes would be, on the one hand, full text indexing, or on the other hand, data lakes, which is a euphemism for no one actually looks at it, unless you're doing maybe data science or due diligence, but that's quite useless in the alerting and monitoring space. So observability is about enabling humans and computers to understand complex systems. And it's about being able to ask why something is working, and not just saying that, yes, it is not working, because that's not going far enough. You need to be able, with the data you already have, ask questions that introspect the system. Another important topic here, complexity. I personally like to discern between fake complexity and real complexity. Fake complexity can usually be reduced. Sometimes you have design constraints, or you have legacy systems, and legacy just being a euphemism for actually makes money. But if you can reduce your complexity, you probably should, or you should at least try to. Like, it's not always the most important thing, but if you can, do so. And there's the thing which is really interesting, and that's this real system inherent complexity. You can move it around, and most of us have seen this, like mainframes, monolithic servers, client server structures, microservices, Pico services, serverless, and then it goes back and forth, large and small. We've all seen this, but you cannot just make this complexity go away. It needs to live somewhere. You see this in databases. Everyone has stateless microservices these days, but someone runs the database, of course, else you don't have your service. It should or must be compartmentalized. We'll talk about services in a second. And ideally, it should be distilled meaningfully. And that has several different meanings. It might be your API or user interface or what have you. And also it means what signals you're emitting from your things to be able to operate and to alert on stuff. SRE, another important buzzword. To me, it's an instantiation of DevOps, and there's people who will violently disagree and people who will violently agree, and both is fine. At the core, to me, SRE is about one thing. Like if I had to choose one, that's one thing, and that is that incentives are actually aligned across the org. If you look at more traditional shops, or most shops probably, you have developers. They get paid by shipping features as quickly as humanly possible. You have program managers and product managers. They basically get paid if the customer is happy and if a random feature, which might or might not be super relevant for other people, is shipped. Operations is paid if everything is running smoothly. And you have tons of others. So everyone is fighting against each other because everyone has their own incentives, their own intrinsic and extrinsic motivations, and they get to fight. And this is a huge problem. SRE is trying to do this away. The best example is error budgets, where everyone shares an error budget. And if the devs do superb work, they can ship all the features, high velocity, blah, 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 deploy on Fridays, no one cares, A/B testing, everyone is happy. Of course, they're not breaking their SLAs. But if they start breaking their SLAs and their SLOs, then they need to reduce feature velocity, which in turn means that the operation people get to dominate and actually need to get help from the developers and the others to make the thing stable again. And as they share this one resource, their incentives are aligned. I mentioned SLO and SLA. They're super simple, but often not simply explained. Service level indicator, objective and agreement, what you measure, what you need to hit internally, and when you need to pay because you broke the contract. The other thing when you start thinking about things in these SRE terms is once you start building, for example, your own your common tools and dashboards, you also have an incentive to invest in shared tooling and you pool your knowledge. All the subject matter experts for the different bits and pieces come together, work on the one dashboard, on the one alert, and everyone learns from everyone else and everyone benefits from everyone else. But the other thing is you don't have the thing where your manager is looking at a different graph and you disagree on what this actually means. Because people build a shared understanding and language of those services and about those services. So what are services? Again, they are those compartmentalized complexities with an interface. Usually you have different owners and teams. And contracts define interfaces. Even internally, I like the term contract. Of course, it's an agreement which must not be broken. Ideally, it's in writing, and only when you put things in writing, people actually find out that, yes, they do disagree on this and that thing before that time, and before they actually sign it, everyone's like, yeah, whatever, and then they fight afterwards. So I like the term contract. Anyone who's cloud native or internet native, I don't need to convince you that layer is a super common concept, and the internet literally would not exist without proper layerings. And that layering is precisely service interfaces and services where you can rip out your token ring and replace it with Ethernet or what have you. Other examples, even if you cook yourself, you're not growing every last cucumber, even if you have plants at home, which I don't. But even if you have plants at home, you're not growing every last cucumber. You're buying your cucumber at some point. And that's also a service interface. All that complexity of making a plant grow and not die is hidden from you. Again, towards the end, alerting. Last one of those basic ones. Customers really, really, really don't care about how your services are made. Like most of them aren't. They care about this thing being up. If you have 1 or 20 database servers, no one cares. Like you care, but not the customers. They care about the thing being there. They don't care if 10 or 20 or 0 of the databases are down. They care about the thing being working. And that's going towards the alerting stuff. Because only stuff which is currently or imminently impacting customers must be alerted upon, and nothing else. As to what to alert on, I personally like to discern between primary and secondary SLIs, and that's not a concept which you'll see often, but I highly recommend it. To just think about it this way. Where the primary SLIs are the ones which you measure for your own thing, and the services you rely upon, their primary SLIs are what you rely on. Of course, if your database is down, you don't need to figure out why your web shop is not working. You can directly go to the source, and you build this pyramid of services, and yeah, it just makes reasoning about outages and such a lot quicker and easier. So let's get onto the technology side. First of all, Prometheus, I'll run through this just in case someone is not convinced or hasn't heard of it, but this will be quick. Prometheus is inspired by Google's Borgman time series database. It has literally tens of thousands of instrumentations and exporters. It's not for event logging. Dashboarding is commonly done via Grafana. It has a highly dynamic built-in service discovery. Most of you will be aware of the file-based service discovery, where you just create a YAML file or several and just start monitoring that stuff, or where you simply point it at a Kubernetes and you automatically start observing everything which is in your Kubernetes. There's also interfaces for various cloud providers. There's a zone transfer system, so you can just transfer a DNS zone into Prometheus, or allow transfer. And Prometheus will just start scraping everything in that zone, which is super nice if you're running networks. It doesn't have this hierarchical data model where you have region, and then you have data center, and then you have customer. And then you need to select by customer, and everything is horrible, and you need to write a ton of for loops and go up and down. You have this n-dimensional label set where you can just slice and dice your data as you need it. You can select by whatever, and it just works. You use PromQL for all this, for processing, graphing, alerting, exporting, blah, 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 blah. It's one language which you have to learn, but it's extremely efficient, and literally all data operations go through this one single language, so it's well worth it. It's pull-based. There's a religious thing about pull versus push. As a network engineer, I prefer, or slightly prefer, pull, but that's for over beer, not for here. Important concepts to be aware of: black box monitoring versus white box monitoring. Black box is the thing is opaque to you. You don't know what's inside, and you just look at what comes in and what comes out. Whereas white box monitoring, you're actually instrumenting your code, as we heard earlier. And you can actually emit with inside knowledge from your code. Every service should have its own metrics endpoint, but with like Grafana and Prometheus agent, you can also have this differently, or just reverse proxies. And for Prometheus, we have extreme. I'm a Prometheus member as well. With my Prometheus hat on, we have extremely hard API commitments within major versions, even in minor versions. What are time series? They're recorded values which change over time. You usually merge events into counters and or histograms. Changing values are recorded with gauges. You're probably aware of this. Just to make certain, this is how it looks. I know a person who is literally print effing from their C code, and then they just dump it on a website, and that's their instrumentation, and it works. Scale: Kubernetes is Borg, Prometheus is Borgman. Google wouldn't exist without either of those, and Kubernetes and Prometheus are designed and written for each other, even if they started completely distinctly of each other, but by their shared heritage, that's why they work so well together. A little bit on scaling. You can expect roughly 1 million samples per second on current hardware, just a random machine. 200K samples per second in core. We compress rather well by over 10x. And the highest or the largest Prometheus which we saw, which wasn't permanently on fire, had 125 million active time series at the same time, which is quite a bit. For long-term storage, there's two things, Thanos and Cortex. Both have huge investment from Prometheus team members. Historically, Thanos is easier to run, but slower on querying. And it started with scaling the storage horizontally, whereas Cortex is easier to run these days. And it started with scaling ingesters and queries and such. Cortex took the code of Thanos to scale its storage horizontally. Guess what Thanos is working on the query and ingesting level? Obvious. At Grafana, the single largest cluster, and that's not all of our customers, that is just the largest cluster which we had as of September this year. We had 65 million active time series at a cost of 670 CPU cores. 3 terabytes of RAM, and we are working towards supporting 1 billion active time series. Actually, that's currently working as a proof of concept, so that's running. Loki. It follows the same label-based system as Prometheus. And one of the nice thing about this is you only index what you need, and you can query the rest at runtime, which means you don't have this insane cost of full text indexing. You can work with logs at an actual scale. There's a super low latency write path, and it's highly efficient. And you have a really flexible schema on read through this label set, and with the combination of LogQL, where you can query all your stuff, then you pull it from the database, and then you can do deeper analysis on what you returned through the initial part of your LogQL query. The bit in front basically looks like PromQL for probably obvious reasons. Yeah, and for syslog and everything, PromTel exists. PromTel is also part of the Grafana agent. You can just dump your stuff in there and directly emit towards Loki. It looks basically like Prometheus exposition format or OpenMetrics format, where you have a mandatory timestamp in front. Of course, events have timestamps, but beyond this, it's the same. And at the end, you have an unindexed thing. In Prometheus context, that would be a number, and here it's just a blob. Ed even has photos from his, well, not self-driving, but experimental car and plaything, where he stores these images in Loki. Of course, he can and he wants to. Loki at Grafana Labs, that is from November. We regularly see queries which peak at 60 gigabytes per second, not gigabit, but gigabyte per second, which in turn means we regularly query terabytes of data in under a minute. And this includes all the added complexity of selecting, reading, and actually doing deeper analysis through LogQL. This is insanely powerful. Tempo. Well, what if we didn't build a third index for all spans and traces? That's actually coming out of the OpenMetrics effort when we were talking to Google and thinking about merging with Open Census. They mentioned that searching for traces didn't scale. And when Google tells you that searching for something doesn't scale, you better listen, which we did. Exemplars are just IDs, numeric IDs. One for the trace, one for the span, optional. And you just attach this to your metrics, to your logs. The reason is quite simple. You don't have this needle and haystack problem. If you look at other high-scale tracing backends, oftentimes they need an insane amount of metadata. And they have this, like they build a literal, well, not a literal, haystack, and then you get to search your needles. Of course, you have all the information and you do massive analysis at a significant CPU cost at ingestion time to actually determine what is happening with those traces. But we already know what our high latency buckets are because we have instrumentation. We know those metrics. We already know where that error occurs. Of course, we have that log line which tells us that, hey, this and that thing happened at this and that time. So we already know which trace is interesting if only it were attached to a log line of interest or a metric of interest. Lo and behold, exemplars, this is precisely what they are. You just attach this ID to your thing, and then you jump directly from those relevant logs and metrics into your traces, into your spans. And you don't have to figure out why this is relevant, because you already know that it's relevant. All that being said, some people prefer haystacks, and we support haystacks. Tempo can index and search on label sets if you absolutely wanted to. Personally, I highly recommend not doing this or moving away of it as you get more familiar with Tempo. You don't need anything fancy, just an object store, done. It's 100% compatible with basically all the things. And we don't sample at Grafana Labs. Data from July, we had a consistent rate of 2.2 million samples per second at a sustained 350 megabytes per second. At 14 days retention and 3 copy stores, the total cost was 240 CPU cores, 450 gigs of RAM, 132 terabytes of object storage, and we had latencies which were absolutely okay. Like, it's better in the meantime. I need to upload the slide, I guess, or force Joe to. But the point is, even like half a year ago, this was already quite fast, and we made huge improvements to tempo since then. So bringing all of this together, all of a sudden you can jump seamlessly from your logs to your traces, from your metrics to your traces, from your logs to your traces, and all the other ways. And all of this is open source, and you can run it yourself. Also, the people at Grafana Labs who you've seen here today, we all like food and shelter. They're kind of nice. So if you want to pay Grafana Labs, totally fine. We sell this stuff. We also run it for you. You can contact us if you want to. But everything we talked about today is completely ours, and you can just run it yourself. A few updates on things which are relatively new, like as of a month ago. You now have the ability to hide your grid lines, details about gradients in your fills and everything. You have vast options to like on the left-hand side, it's all the same data, just visualized differently. On the right-hand side, that's one thing I'm personally super happy about. Of course, this will hopefully lead towards weather maps and also like state diagrams for industrial power plants, blah, 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 blah. If you want to hear more about all of those, we just recently had our OpsCon 2021, and you can just go here, or you can also download those slides later and click on this. Of course, they see a lot more of what I just talked about, and that's it.
Yay, I'm too slow with hitting the unmute button every time. I don't know what that is. Thank you, Richie, for your talk. Let's have a quick look at the results of the poll that we did just before you started. Let me see. What do you think? Is it what you expected?
I mean, myself, again, I'm coming from a networking space, so metrics are the default. Of course, again, the networking space already hit all those scaling issues 2 decades ago. And the thing which you see again and again and again and again is that people, when they have large amounts of data, they turn singular events into numbers and into summaries and into things which change over time. Like that's been the case for the last 7,000 years or so. So personally, I prefer metrics. That being said, oftentimes I see people need to start off with logs because they don't have metrics in place already. Seeing metrics slightly ahead is quite nice.
Cool. I'm also quite happy that people are looking at the mix of it all. So that's good for us, no? Awesome. There's some really good feedback in the chat, so that's super nice. Vitaly has posted a link to your talks repository on GitHub, so that's super useful for sure. Let's see if we can take a question. I see something by Vlad, who was also posing a lot of questions about the monitoring houseplants talk. What about running? Oh, wait, sorry, you didn't share your screen anymore. What about running Prometheus on Raspberry Pi inside Kubernetes Lite? That is right, cluster. From my experience, Prometheus seems to consume a lot of RAM initially.
Check your settings. Prometheus is like from the default config, it's made to be quick, and part of this is just hogging a ton of CPU initially. Here under my desk, I have a machine with, I think it's 512 megabytes of RAM. Like it's not a Raspberry Pi, it's an AMD 64 machine, but it's an industrial PC, and it absolutely works fine. It might be a gigabyte of RAM, but like it's not a huge amount, and everything is working fine. But I did change the settings a little bit.
Awesome. Well, I'd be curious if Vlad tries this out, that he sees the same results. Other than that, because I don't see any more questions, I think we're ending on a high energy note. Thank you for that, Richie.